Okay. So let me see what was I saying? Yes. So
Sorry, you were saying that a specific
group.
you were saying that a specific group of people were interested in
Yeah.
book introductions.
Yeah. So this group, of course, is the people who are in charge of determining whether the book is dangerous or not, right? This would be people within the church. Later in this course, maybe by the 1720s, 30s, 40s, 50s, every government in Europe has set up a public censor, someone who reads every single book that comes out and approves it or doesn't approve it, right? This is one reason why printers might be located in particularly tolerant areas where censors wouldn't be, so they could publish books that were banned in other places. And wouldn't it be great press if a book is banned and then you publish it secretly, right? In a place, you can sell it to lots of people who want to see the banned book, right? So being banned wasn't necessarily a bad thing. But Copernicus didn't want to be banned. But important thing is, do you think, well, they wouldn't, the people within the church who read this book, it wasn't banned. Why? Well, they were not experts in astronomy, right? They probably only read the first few pages. And you'll see the first few pages are so emphatic about this not being a book about the universe that has any ideas that you should care about. Basically, the entire foreword says there's nothing to see here, right? Pass on. Everything here is just for specialists. It doesn't talk about truth, nothing. Don't worry. And after reading that, the church, not surprisingly, just, let it pass. It wasn't later until the Pope actually asked Galileo himself what he thought, that Galileo told him, any person who reads the whole book will realize that Copernicus did not write the preface, or what's called the foreword here, right? It was written by someone else, and in the original version, it didn't say it was written by someone else. That's one of the things the editors have changed here, right? Interestingly, the editors have placed at the beginning a note so you don't become confused, right? Foreword by Andreas Osiander, but that wasn't there for the first 200 years of the existence of the book, right? That was placed later. And then I have to place a footnote telling you, don't read that, or at least realize that wasn't there originally, right? It wasn't banned until, surprisingly, right, Galileo led to its being banned and condemned himself, because he told the Pope, yeah, it actually does say what you might fear it says. Now, so importantly, Copernicus's voice does not start until here. Everything else is someone else's voice. And he himself tries to explain why his book is not dangerous. But it's very confusing, as you'll see, if you think both are Copernicus, because they sound very different, right? They use different language. So that's the other thing. When, or there's even one more, which I will talk about. But when you're writing, prefaces and introductions are important because they show us the social context and how the author wanted their work to be received. And they have to, for them, those parts were probably the most carefully constructed parts of their work, right? Because that's what people would read first. That's also what people would read when deciding whether or not they're going to buy the book or not, right? So it also has to have something there. This fact that this is what the censors and the politicians are mainly going to read and nothing else is why books of this period almost always begin with all kinds of fantastic letters to the authorities, to the Pope. This one has a letter to the Pope. The others will have letters to the kings. And what do they say? Greatest king of kings, wisest person, friend of the humanities. We all depend on you for everything. I praise you. This book is in your honor. This happens all throughout the period, right? This fawning relationship to the authorities. And it's in this book too, not as much as in later books though. The final,
Professor,
go ahead.
did you not feel like he was very apologetic? Like in the first few pages, it feels like he's apologizing for what he found and what he's studying and what he wrote for like most of the time. And he's like apologizing.
Yeah, you're talking about in this part of the text, right?
Yeah, and even in the introduction, a bit like slightly, you see him not apologizing in the introduction. In the foreword, he apologizes, but then in the introduction, he goes like, the reason behind this, like he's just trying to like justify what he found and like why he's writing this.
So
and, like,
let's
I
be a
felt
bit
like
careful, right? In the foreword, there's no apology because essentially the explanation is there's nothing to apologize. And this is not by Copernicus. Here, you're right. In this letter, there's kind of some, he's trying to, there's kind of it's an apology in a normal and in a kind of traditional sense. Like he wants to explain his reasons and show that his reasons were not bad reasons. And that he's honestly just trying to present what he knows and thinks is true. And he hopes the Pope will accept that. And he didn't do this for bad motives, like he wasn't trying to become famous and so on. So here there's a bit of an apology. In the beginning, there's nothing to see here, so there's no need for an apology. And then in the introduction, which down here, this is actually where the book itself begins, right? This is all preface material. This is where the book itself begins, and the book itself has its own introduction, because this is Copernicus knows his genre. The genre here is a kind of theoretical treatise in astronomy. These have been written since ancient times. There were great examples, and he's following the examples once he gets into the book. Once he gets into the book, it's structured like a book by Ptolemy or by an Arab philosopher, right? It's going to have a very similar structure to it. But that's, once he enters the book, it's going to be different, right? But these prefatory parts have other functions and purposes that they're trying to achieve. The final point, I know I'm making point after point after point here, but the final point is in this period, I've already told you this in the general lectures, that essentially there is this boom of particularly scientific thought in what we call the area of physics, right? Astronomy and mechanics. And the great success of that seems to come about through the idea that mathematical models provide real explanations for the phenomena, right? That's the main idea. And also some developments in instrumentation and experimentation. Now, there was this, if you read the PDF I attached to my first lecture that you could download, there's a final section about systems in this period. And the idea was, this is it, that what this new mathematical science reveals to us is that the world has a kind of mathematical structure to it. It's systematically unified, and just like mathematics, there are more basic things and there are complicated things, and the complicated things happen and are explained through the simple things in science, right? And you can understand the laws and rules that govern nature. And once, for instance, you understand the laws and rules that govern the behavior of gases, then you can explain how something like a barometer works, right? That determines the pressure. Or once you understand the mechanical principles behind a buoyancy, you can explain why this ship here floats in water, right? You can do that mathematically based upon calculating densities and so on, right? So everything complicated in the world should be explained through something more simple. And the theory itself, and it can be because science is working, everyone got this feeling that maybe the world, it's the reason, the presupposition of science is that we can explain and create a science because the world itself is truly structured and ordered and has laws. if the world has structure, only if the world has laws and rules and structure, can it be possible for minds to understand that structure and then have a science that explains that structure, right? Now, that's the basic presupposition, that the world is a system, a scientific, mathematically explicable system. And people began, based upon the model and the success of astronomy, to think that might be true in lots of areas, maybe in all areas. Like maybe the mind has laws and rules that we can study to explain behavior. That's the origin of psychology, right? Maybe the political world, political reality has laws and rules that it follows and basic concepts that can be used to explain what the best possible form of a government is. That is the origin of political science, as we'll see. It's an extension of the kind of thinking we see in Copernicus to other domains, right? They even thought that aesthetics, beauty, art, maybe there are laws and rules for what governs a beautiful work of art versus a poor work of art. And if we learn those rules, we can explain why the Mona Lisa is so beautiful and the one that I painted is not. And maybe by following those rules, we can make better art as well, right? Same thing with politics. If we know those rules, we can explain why some governments function well and others do not. And maybe we can improve the government that we have. So the extension of the science idea led to the belief that, well, all these areas are systematic and structured. And if you're an author and you're explaining a science, then maybe you should make your book structured like the science should be structured, right? With the basic things coming first and the complicated things coming last. And you should mirror in your book the structure of the science, which also is, of course, mirrors the structure of the universe, of the world. So the beginning of your book, if it's psychology, should be the most basic laws and principles of psychology. And in later parts of the book, you look at specific phenomena and explain them. That all makes sense to you, right? That was an idea invented in this period, as it were, and they took it very, very seriously. So the first sections...
Wouldn't that be also the main disagreement between Copernicus and Ptolemy? Like, Copernicus thought that Ptolemy wasn't based on any empirical data and any certain set of laws.
Well, Ptolemy was based on exquisite empirical data, but the other point, you're correct. There's no system to it for him. There's no like basic idea that everything else follows from. And Copernicus has such an idea. What it is a good question. Think about it, and I'll ask you that a bit later. What is his fundamental idea? But he will say this explicitly. There's just no good system in Ptolemy, but I have a system, right? My system is orderly and structured and so on, but yours is not. But you have to understand what he thinks the first principles are before you understand exactly what the system is. I'll tell you now, the mistaken assumption that most of you would have without reading this text, based upon your previous knowledge of Copernicus or incorrect knowledge of Copernicus that you get through popular things, is that his fundamental idea is that the sun is at the center of the universe. Many of you would probably, if you ask what is the fundamental idea of Copernicus, you'd say heliocentrism, right? But some of you are shaking your heads. You probably noticed when you're reading that heliocentrism is almost not discussed at all. And it's certainly not discussed at the very beginning of the work. Something else is discussed, right? What is that? Does anyone have a guess there what that is?
Motion.
I think he stressed a lot about how the Earth is spherical and that it moves at first, and then he went on to say that everything is connected and that there's systemic harmony and that everything affects, every single object in the universe. So I think that was the first main idea of the book.
Yeah. So we have to be a little careful here. Certainly, his actual main idea is not going to be the first idea in the book, because there's some even more basic ideas like the planets move on circular orbits and so on, and those he shares with all previous astronomers. But his key idea is, as someone mentioned, and it comes very early, and it's repeated throughout, is the hypothesis of the motion of the earth. That the earth moves. That is the fundamental idea. Now, why is the sun at the center? Because the sun has to be at the center to get the data to work right. That's the only reason. He didn't want it to be at the center, though when he finds it at the center, he thinks, well, that seems right. The sun should be at the center because God wanted to illuminate everything equally, and it sounds good to me. He says this later in the book, but this is not his driving thing. He didn't see himself as changing the model of the universe. That was not his goal. It was simply to explain the data, and the hypothesis of the motion of the earth led to a breakthrough. Everything worked in a better way, we'll see. Became systematic and ordered and structured. So all of this is just to say, the beginnings of the books are very important. These are where the fundamental basic ideas get explained, that everything else depends on. Also, since there's still the question how you reach those fundamental ideas, right? Also, authors in this period, because they're doing something they think new, they want to explain how they reached those new ideas because for so long people were wrong, how can I suddenly be right? So the introductions are where they usually talk about their methodology, right? This is why the beginnings and introductions are so important as well. So generally, introductions will be, here was my goal and my purpose, here was the method I used, here's how I discovered my method, and here is the structure of the science that will come out of it. And then they start the first part of their book with the first principles, and they derive everything further. We'll see this pattern over and over and over again, right? That's how John Locke writes, this is how Thomas Hobbes writes, this is how René Descartes writes, and so on, right? We'll see it over and over and over again.
And this way kind of convinces you more.
If you
into
are,
believing their idea.
it convinces us, right?
Yeah.
If you believe that the only true source of certainty, as the church did, is revelation in scripture, it doesn't convince you at all, right? It convinces you that the author thinks a lot of himself.
Mm.
That it's like he's building a world there, right? This is what the church's view was. It's vanity, right? This is bad. This is human vanity, believing you can see the structure of the universe and understand it with your mind.
Yeah, the way I thought about it is totally different.
Yeah. So we'll see that this is actually indicated in Osiander's preface. The problem with this view with the church and so on is mainly that it challenges the authority of the church and the authority of scripture, not because it says something different, but because it has a different method and it tries to reach certainty itself, right? Which the church wouldn't allow in general. So when we look at the first, let's turn to the actual text. You'll see here's a translation of the first page on 6 books on the revolutions of the heavenly spheres. This is just the publisher's notice, right? But this is from Copernicus himself. It says, "Let no one untrained in geometry enter here." Is anyone not looking at the footnote? Do you know what does this come from? It's written in Greek originally, as you can see on this next page. And in the original, there's no note to say who said it or wrote it because everybody would have known. Anyone guess?
I cheated, but it's Plato's.
So we have an honest cheater. So it's from Plato. Supposedly it was written above the entrance to the academy. You know, this was where Plato taught. Plato, if you look at Plato's philosophy, you know, he has this philosophy of the ideas, these ideas that are pure realities outside of the world, these ideal things, triangles, but also goodness and so on, right? Justice. These are the Platonic ideas. They're eternal and realities. The world we live in is not the real world, and so on. And geometry was very key in the biography of Plato, because before he was Plato, the Platonic Plato, he was a follower of the Pythagoreans, which was an ancient group of philosophers who worshipped, even religiously, numbers. They had a religion based upon numbers and a kind of cult, but also they were philosophers and mathematicians. They saw numbers as divine. Very interesting group of people. You've heard of them, of course. And so there was always this notion in Plato and in previous thinkers that kind of the ultimately highest intellectual things, the model of real knowledge, the closest we have maybe, is mathematical knowledge, geometrical knowledge. It seems to be more perfect than all other kinds of knowledge. Now, Plato thought there was something even above mathematical knowledge, which is like knowledge of the good, knowledge of justice, and so on. This was even higher than mathematics. But mathematics was kind of, what's interesting about mathematics is it's a practice, right? You become skilled. You cannot just do mathematics straight off. You have to learn a way of thinking, right? That way of thinking and that method of thinking was for Plato the kind of model for how you should do philosophy, right? It's the kind of insight you should look for in all intellectual things. Now, so don't enter the academy and try to learn philosophy until you already know geometry, because you need some skills in that kind of thinking, right? Many people today, you guys probably don't associate science and mathematics with philosophy very closely, right? But in the ancient times, philosophy was the highest science, right? It was supposed to be even more superior to mathematics and closest to mathematics. This is true also of the ancients and to a certain extent of Copernicus and others. But what he is saying here, and this is, you see this throughout the text, is he knows that this book, if you open it up and you hear the earth rotates in not one, but 3 circles, right? On his model, there are 3 circles. We move around the axis of the earth on the earth, right? How fast? Anyone have an idea? How fast you are moving right now around the center of the earth? Guess. Slowly, quickly. What do you think?
Slowly, I would assume.
I'm pretty sure it's really, 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 really fast.
Yeah.
So,
For us not to feel it, if it was slow, we'd feel it. But if it's really, really fast, we wouldn't, right?
You would think we would feel it almost no matter what, but we don't. And it is really fast, right? You're moving now at over 1,000 miles an hour around the center of the earth. The earth itself is moving at something like 22 or 23,000 miles an hour around the sun. Also, at the same time, the earth is wobbling like this. That's quite slow. So there's 3 circles there. The circle of the rotation of the axis, the earth going around its own axis, and the earth going around the sun. We now know, of course, that the sun itself is spinning around the galaxy at hundreds of thousands of miles an hour. That the galaxy itself is traveling towards the center of the universe at even faster speed. So you are moving very, very quickly in some incredibly complicated spiraling motion throughout the universe. And yet, it doesn't seem like it, of course. You could see why telling someone this would make them think that you are insane. Because jump on a merry-go-round and spin at 1,000th of the speed that you are moving on the earth, and you will fly off immediately. You've all had this experience? When I was a kid, the playground, we had these things you spin on, right? And the big kids would always come and spin it really fast. And you would get hurt, right? It's a pretty brutal force that throws you off even at the speed that they would spin it. And now think you are on the earth and you're not flying off or feeling it at all. It's completely undetectable to you. Try to understand that. I think personally, it's impossible to understand. You just have to kind of take it on faith that all these weird things are going on that makes it so you can't feel it, right? Inertia and so on and so forth. So in other words, Copernicus knew this was going to sound crazy to anybody because it sounded crazy to him. And he was only driven to it through mathematical, scientific, structural reasons as the only possible solution to a lot of problems. And so that's what he has in mind here. He's saying,
Sorry, Professor, I have a question.
yeah, let me finish that sentence.
Of course.
He's saying, if you open this book and you read it, you're not going to get anything out of it. You're just going to go away thinking this is craziness, unless you are trained like I am to see the power of the scientific arguments involved, right? And so that's really what he's saying. He doesn't want his book to be misunderstood by people who are not equipped mathematically to understand it. Yes, Marwa.
Yes, sorry. My question is from the video that I saw, that I watched on the website, I understood that Ptolemy was the one who based his information or his outcomes like mainly on mathematical data. And I was under the impression that Copernicus did not, that it was all, and it has nothing to do with mathematics, and it was all like, he noticed and he thought. So what's wrong in?
Yeah, what's wrong in that? Well, we need to make, making one distinction will help you out there. There's mathematics in terms of data, measurements. Both, Ptolemy made amazing measurements, and those same measurements and data were used by Copernicus. But that data was perfectly fit by Ptolemy's model and by Copernicus's model. So that couldn't be the reason. Empirical data couldn't really be the reason that Copernicus came to his new idea. So then you say, well, maybe it's not mathematical, but there's other aspects of mathematics than just data, right? There's like, and some of his, what we would call mathematical reasons don't, for us, sound as any longer very mathematical. Like, he believes that everything moves in circles because circles are perfect, right? That is a mathematical reason for Copernicus. For us, we don't think about perfection in mathematics anymore, so it's kind of been excluded. But it's something that only a mathematician would appreciate for Copernicus, and that makes it a mathematical reason. Harmony, order, the structure of the model, these are mathematical reasons, right?
Okay.
Simplicity, those are mathematical reasons. And you're right, to us, a lot of those would now fall into the field of aesthetics, right? Kind of mathematical aesthetics. But that is, of course, you know, and it's still used in science. Someone like Einstein, one of the major appeals of his own theory, he could not prove it, right? General relativity had no empirical evidence for like 15 years after he wrote it, but he was certain it was true. And that was for mathematical reasons, but the mathematical reasons were ones of order and beauty and so on of the theory itself, right? So,
Yeah, thinking.
Yeah, sure. Now, I put a lot of emphasis here because although this line was understood in this way by perhaps Copernicus, later it would take on a much different significance, particularly in Galileo, who had a similar idea. If you are looking at this sentence from the point of view of the church, it means something different. It says, you cannot read and understand the universe unless you are a mathematician. Wait a minute. I thought scripture was supposed to teach us about the universe. Are you claiming, Copernicus, that you have more authority to tell me about the universe because you're a mathematician than the interpreters of the Bible? Now, Copernicus would probably not like that question very much. He doesn't know what to do about it. But Galileo and later thinkers, their claim is yes, sorry, but science has more authority about certain things than the church does, right? And so don't judge it unless, you can be a priest and judge it, but you have to be a priest who's educated in science, in the methods of science, right? So you can see here the underlying challenge to at least the traditional idea that we understand nature primarily through reading Genesis, right? That's how we should understand nature first and foremost, and through the Bible. So we are, what time are we over? 1:45, is that correct?
Yeah, we finish at 1:45, 15 minutes.
Okay. Good, so we will get somewhat into this text at least. So you can see that significance. Galileo later had a very famous version of this. He wrote in a book that the universe is written in a language that if you don't understand that language, you can't understand the universe. And he said that language is the language of mathematics, of circles and squares and so on. So he has this very famous quote. If you go to the Galileo Museum in Florence, you can see his telescopes he used, and that's emblazoned on the wall as this quote, right? It sounds great. It sounds really amazing. It sounded really dangerous to a lot of people, right? This kind of a claim. Though Copernicus didn't mean it that way, though Galileo knew entirely what its significance was. So anyways, so getting into the text itself, we look at the foreword. Again, this foreword is not written by Copernicus. It's written by a friend of his who was a Protestant preacher or someone in the Protestant church. Wrote it when Copernicus was no longer able to say anything about it. And we'll just start reading it, right? So to the reader, concerning the hypothesis of the work. Pay attention as we start reading here to the use of the word hypothesis, and tell me if you notice anything strange, right? So he starts off just by saying that scholars might be offended by the contents of this book, right? And they might be confusing things. So he wants to explain why they should not be offended, and wants to warn them not to make a certain confusion. He's going to repeat it 4 or 5 times, the same thing. In other words, he's really emphatic about this one thing they should not confuse, right? Now, what is that? Someone want to begin and volunteer to read here? This is where he starts to explain it.
I can read.
Okay, please do.
For it is the duty of an astronomer to compose the history of the celestial motions through careful and expert study. Then he must conceive and devise the causes of these motions or hypotheses about them.
Okay,
Since
stop
he
there.
cannot...
Stop there. Stop.
Okay.
First sentence. It's about the duty of the astronomer, right? So he's going to tell us what's the goal, what are astronomers assigned to do, what is their job. And their job is to, quote, compose the history of the celestial motions. What does that mean?
Like, when did they originate? When did they start moving? How do they move? Why do they move? Everything.
Yeah, so that would be one's assumption, right? From the word history. Like you're just taking the word history and you're saying, well, what would a history of the celestial motions be? And that is not correct, but that's what one would assume, right? Does someone have another idea?
By saying the history of the celestial motions as in how it moves and the time it takes to move.
Okay, so the idea of, this is one of those great examples of a word that we use very differently. Though you are familiar with some versions of it. You've probably heard of the term natural history, right? If you open up a book on natural history, it's not about the past. What you're going to find is like lots of diagrams and stuff of the structures of birds and animals and descriptions of nature as it is now, not as it was in the past. history originally just meant data recorded. That's what it is. If I go into a laboratory right now and I were to measure the temperature of a solution and I wrote it down, what I've written down there is called history. I did it just now. It's still that temperature. But in this language, history is just data. That's what it means, right? And it might be also data about calculations of the future. That's part of natural history. So history is not only not of now or of the past, it can include stuff about what's going to happen tomorrow. So that's very counterintuitive. But when you understand it's just about describing phenomena, then that all makes sense, right? Because phenomena could be what I'm predicting what I will describe tomorrow. So importantly, the distinction is between history, which simply records and describes, and explanations. Physics is explanation. Science, natural philosophy is explanation. History is record and data. Okay, so he's saying the astronomer, part of their duty, this is not their whole duty, but part of their duty is simply to record what goes on in the skies, right? Through careful and expert study. Make measurements, write it down, put it in books, and so on. Then, and now, would you like to start again? Continue reading the passage. Yeah.
Then he must conceive and devise the causes of these motions or hypotheses about them.
Okay, keep going.
Since he cannot in any way attain to the true causes, he will adopt whatever suppositions enable the motions to be computed correctly from the principles of geometry for the future as well as for the past.
So what does that mean? Anyone?
I think the person who wrote this introduction is trying as hard as they can to say that an astronomer does not have truths, you know, and I think because they don't want to make the church angry, they just want to say that these are hypotheses according to geometry or math that explain what we see, but they don't have to be true, which is weird. They
compute, right? A good example of this, or kind of a parallel example, would be like, so there's maybe you've heard of this famous, he's dead now, but Nobel Prize winner named Richard Feynman. He used to tell this story about the ancient Mayans had this book, right? The ancient Mayans in the Americas had a book about their gods. And if you read it in a certain way, you could use it to tell where the moon would be during certain times of the year. It was predictive. But it was a book about the gods and their fights with each other and so on, right? And what's interesting is that had a structure that could be used to predict, but certainly you and I today don't read that book and think that it explains why the moon is in the sky at that time of year, right? To them, it explained the moon was maybe put there and was there because of certain things the gods did. But it works, it calculates, but you and I would never presume it to be true, right? Same like your calculator can be used to calculate where the moon is in the sky, but you don't think your calculator is the explanation for why the moon is in the sky, right? Same here, saying the astronomers just take the data, they make models, mathematical models even, to fit the data and to predict future data, but they cannot in any way attain the true causes. Why? Because the method they use is not the method that can give you truth. They fundamentally, it's not only that they don't try and they might try and fail to get the truth. The method they use is entirely unfit to find truth at all, right? Why? Because it relies on mathematics. This is that old Aristotelian idea, right? If you want truth in natural philosophy, you need to use natural philosophy and the kinds of reasons that Aristotle gave for things, right? That's the first interpretation here. Just straightforward Aristotelianism. And so you don't have to worry about the hypotheses of this book. If it puts the Earth at the center or the sun at the center, who cares? It's just a fantasy that Copernicus made up to do calculations, right? Now, so that's what he's saying. They cannot in any way attain the, so because, and this is nice, it says, well, because he can't attain the true causes, in a certain sense, he has all the freedom he might desire to say anything he likes, as long as it works, right? That's the only true judgment to be made, is does it help to calculate the data or not? If it does, it's good. If it doesn't, doesn't, it's bad. And it doesn't matter if it's based on elephants or whatever, right? Now, if you go a little further here, and this, already the word hypothesis is being used strangely, but here you'll really see it in this sentence. For these hypotheses need not be true or even probable. On the contrary, if they provide a calculus consistent with observations, that alone is enough. Right? Now, what's weird about that use of hypothesis? What is a hypothesis for you and I?
It's a claim that we try to test.
It's a
through
prediction.
experiment.
It's something that we think may be actually true, like
Yeah. If someone, if you were in a class with someone and they said, well, I have this hypothesis, but I think it's obvious, it's false. You would say, you don't know how to speak English.
Yeah.
Right? You see, that's nonsense. But here he's saying straightforwardly, the hypothesis, you can have a hypothesis and not necessarily think it's true at all, even possibly true. So what's going on here? Well, hypothesis is a very old word. It goes all the way back to Greek. And hypo means under. So the English word, of course, doesn't go back to Greek, but the roots of the English word go all the way back to a word like it in Greek, used also in Latin here. Hypo means under, and thesis means to put or to place. So it's much more akin to our English word suppose or supposition. Now, if you replace hypothesis always with supposition, then it makes more sense. So for instance, I could say, suppose Bill Gates were president of the United States. Maybe he would give us all free computers. I don't know. Right? Maybe he would make it law that everybody had to use Windows. You know, who knows what he would do. But suppose, if we were to suppose that, what would follow, right? I can suppose that pigs could fly. And I would say, if that were true, it's not. I don't even suppose it's remotely true. But if it were true, then they would have to have very big wings, right? Because they're very heavy bodies, and the wings would have to be powered by muscles that are very strong, and so on. Maybe so on and so forth, right? I'm just supposing, or you could, sometimes we say this, suppose for the sake of argument that, right? So used in that way, there's no need to assume that it's true. The only time you would need to prove the hypothesis is if your supposition were that it was true, right? You could suppose it was true and then you'd have to prove it. But I could suppose something without supposing it's true, right? For some purpose, and that's what he's saying here. So hypothesis, keep that in mind. Hypothesis doesn't mean it's necessarily true. It also doesn't mean it's not true, or it's not that hypotheses have to be not true or even not even probable. They could be either, right? Depends on whether you suppose them for some calculation purpose alone, or you suppose them to also be true. Now, Copernicus supposes them, his hypotheses, he does think are true, and he thinks they're good for calculation, and he thinks the fact that they work for calculation is part of the evidence for them being true. Notice that's a really, really difficult problem here for people working in this period. Included in this idea is that something can perfectly well be used to calculate and predict. and yet that is in no way evidence for its truth. How do you get started then with science? Right? If you can always go to the laboratory and say, well, I've come up with this theory and I've done all these tests and I've calculated all these phenomena and it checks out with all of them, and I say, nice, doesn't mean it's true. You say, well, then how do you prove it's true? I'm saying, well, it's actually impossible on this way of thinking because the tests, the data can't prove it's true. You need something else. This is why when people in this period are trying, like Galileo and others, trying to change people's minds and persuade people that their theories are not only calculating devices, but are also true, they have to actually go beyond science to try to change their minds about what truth is and how truth is reached. That's a major thing. That really does challenge everything in the past, particularly the authority of the church and so on, because it says we've cornered the market on how you determine whether something is true or not. Right? We've figured that out, and now instead of it being the case that calculation and measurement is not the way to reach truth, we have the view that it's the only way to reach truth, right? Mohammed raised his hand. I don't know what that means exactly, but you want to say something?
Yes, but we don't prove truths in general, we just fail to reject them from a mathematical perspective.
Sure, that's a modern.
Like you have a hypothesis, and if you don't have sufficient data to disprove it, that makes it true.
Sure, this is I mean, this is a very, very contemporary idea, and it's true, but only to some limited extent. When scientists are being very careful, they say we never prove anything is true. We are only haven't falsified it. But when they're working in the laboratory and every day, they talk about proving things are true all the time. But you're right, that's a kind of very contemporary philosophical idea in the method of science that people sometimes remember they think, but often forget that they think that. But it certainly wasn't part of Copernicus's, just nothing he'd ever thought about, right? And we'll see in particular, this is a good point to raise because for people like Descartes and others we're going to read in this period, they really think that they can prove truth. They have a method to prove truth, right? So that modern, that contemporary idea that comes from Popper, a falsification, that's actually a little bit of a reaction and a rejection of some of the basic ideas of people like Copernicus and others, because it's regarding methodology, it is. Okay, so we have reached the end of our time. Someone else raised their hand. Any questions before we go?
Oh, thank you.
Okay. No?
No, thank you, Professor.
No, thank you.
All right, have a very good weekend, all of you.
Thank you.
Professor,
Likewise.
just making sure, so the annotations are not like specifically due on the 20th, right?
No, I mean, only in your minds.
Okay. Okay. Thank you.
All right. Okay, I'm going to end the session. If it will let me.